Hello everyone, this is mathematics lesson for grade 8. This program is organized by Addis Ababa City Administration Education Bureau in collaboration with Addis Media Network. I'm teacher Mamo. Today we will have a discussion on two main points. One of the point of discussion for today is test for similarity of triangles, and the second point of discussion will be the relationship between the ratio of perimeters of two similar triangles and the ratio of the area of the two triangles, right? So before I proceed to the present lesson, I want to remind you some of the points from the previous class discussion, okay? If you remember, in our previous lesson, we have seen one of the method of checking similarity, which is called angle-angle similarity theorem, okay? Do you remember what the theorem says? Well, angle-angle similarity theorem tells us if two angles of the corresponding triangle is congruent to two angles of another triangle, then the two triangles are similar. So from this theorem, we understand that to say two triangles are similar, we need to have two congruent corresponding angles, right? So based on this theorem, we have seen some examples that requires the concept of angle-angle similarity, right? So now we will see the next test for similarity, like side-angle-side similarity theorem. And the third one is side-side-side similarity theorem. Okay, let's see these two things first. Okay, theorem for point 2. Theorem for point 2, it's about side-angle-side similarity theorem. Okay, so this theorem tells us if two sides of one triangle is proportional to two sides of the other triangle, and if the included angle in both triangles are congruent, then the two triangles are similar, right? So this theorem tells us if two sides of one triangle is proportional to the corresponding two sides of another triangle. Okay, this is one thing. We need to have two sides which are proportional to two sides of the other triangle, and the included angle in both triangles are congruent. The included angle in both triangles are congruent, then the two triangles are similar. The two triangles are similar. Okay, here in this theorem, we understand that we need to have two corresponding sides that are proportional, and the included angle in both triangles are congruent, right? To say the two triangles are similar. So shortly we can write like this. Thus, if AB over DE is the same as BC over EF, okay, we need to have two proportional sides, and the included angle B and angle E are congruent, then triangle ABC is similar to triangle DEF. Okay, so based on this theorem, let's check or let's see a certain example that requires this this theorem. Okay, a simple case of this theorem is consider this triangle. Show that triangle ABC is similar to triangle DEF, where the two triangles are say ABC, and say the other triangle is DEF. Okay, assume the side of AB is 5 centimeter, and this one is 6 centimeter, and this one is 10 centimeter. Say this is 12 centimeter. One more information about these two triangles is assume this is 35 degree, and this is also 35 degree. So in this example, we are asked to show that these two triangles are similar, right? So to show these two triangles are similar, we need to remember the theorem 4.2, which says which requires two conditions. One of the condition is the ratio of the corresponding sides of the two triangles must be similar. The other criteria is there should be one congruent included angle in both triangles, right? So clearly angle B and angle E are the same, right? So we have one condition. The other condition is the ratio of AB. Okay, you can take AB, if these two are similar, AB over DE, this is the same as BC over EF, okay? BC over EF, okay? We need to have this condition should be fulfilled, right? So as you can see here, AB is 5, and DE is 10, okay? The simplified form of 5 over 10 is 1 over 2, as you can check. This must be BC over EF must also be 1 over 2. Otherwise, these two triangles are not similar. So BC is 6, and EF is 12, okay? Clearly, these two fractions are the same. If you write these numbers in their simplified form, both of them are 1 over 2. So there are two conditions which are satisfied in these two triangles. One is they do have congruent included angle. The other one is the ratio of the corresponding sides are the same. So your conclusion will be these two triangles are congruent by side angle side, right? So this is how you need to show. Well, so now let's see the third test for similarity, which is about side similarity. Okay, theorem 4.3, which is the third theorem, and this theorem tells us side similarity. Well, in this third theorem, two triangles are said to be similar if all sides of a triangle are proportional to the corresponding sides of the other triangle. Okay, so if all sides of one triangle are in proportion to the sides of another triangle, another triangle, then the two triangles are similar. Okay, so shortly, this theorem is saying that the two triangles or any two triangles are similar if this condition is satisfied. What is that condition? The ratio of all corresponding sides of one triangle is similar to the other triangles, right? So shortly, we can say that if AB over DE is the same as BC over EF and AC over DF, okay? Here we can see that the ratio of three corresponding sides of a triangle. If this is true, then we can conclude that triangle ABC is similar to triangle DEF. Okay, so three of these theorems follows different approach to check whether two triangles are similar. So the third theorem tells us, or the third theorem requires only the comparison of the ratio of all the sides of a triangle, right? So to explain this thing using example, let's see the simple case. Show that the triangles below are similar. Okay, suppose we have two triangles with side lengths 3, 5, 6, and the other triangle say 6, 10, 12. Okay, if we have these two triangles, here we are asked to show that these two triangles are similar. Okay, to show the similarity of these two theorems, the theorem that we need to use is side similarities, right? Because we are going to compare the ratio of three sides, right? You cannot apply angle similarity or side angle side similarity that we used before, right? So if you take this number by this, okay, 3/6, okay, the second ratio can be, you can compare these two, okay? If you take this over this, you need to take this over this, okay? You need to compare 5/10, and lastly compare 6/12, okay? Now, to be able to compare these three fractions, you need to convert these numbers in their simplified form. So the simplified form of 3/6 is 1/2, and this is 1/2. This is also 1/2, okay? We have seen how fractions can be simplified in our lesson in the first unit. So clearly, all these ratios are the same. There is a constant of proportionality, which is 1/2. So from this, we can conclude that the given two triangles are similar by side similarities, right? So testing or checking whether two triangles are similar or not is a very simple approach. So you can use those three theorems to determine whether two triangles are similar or not. Good. So let's proceed to the other point of discussion for today. That point is the perimeter and areas of similar triangles. Similar triangles. Okay. So under this topic, we will try to see a certain relationship between the perimeters and areas of similar triangles. So to explain this thing, I will take two figures, two triangles, so that we will see the relationship between sides, perimeters, and areas, right? I will try to include side in this topic. So consider this triangle. Consider this triangle. Triangle ABC and triangle DEF, and assume triangle ABC is similar to triangle DEF, because we are going to talk about the relationship between perimeters and areas of two triangles where those two triangles are similar. So if we have these two similar triangles, suppose we have altitude drawn from A to some point, say D here, okay? If we have an altitude, say that altitude is H1, and the altitude drawn from D to a certain point, say G, and say this altitude is H2, okay? Now, we will try to create a relationship between the altitudes and the sides first, then we proceed to the perimeters and areas. Here, if these are altitudes, they form 90 degree, right? They form 90 degree. The other thing is triangle ABC is similar to triangle DEF. That means these angle C and angle F are congruent because of the similarity of the two triangles. Now I need you to take two other triangles from these two figures, okay? Consider triangle ADC, okay? Consider triangle ADC and triangle, okay, to avoid similar notation, let me change this by a certain point, say M. Now I need you to consider triangle AMC, okay, AMC and DGF, okay, triangle DGF. Look, if you compare these two triangles, they form 90 degree at this point, okay, and this point, okay. The two triangles have one congruent angle. The other thing, by similarity of triangle ABC and DEF, angle C and angle F are congruent. So we can say that AMC and DGC are similar by angle similarity. Okay, we have seen what angle similarity looks like in our previous class discussion. So from this figure, we can extract these two triangles. Okay, we can extract two similar triangles. So if these two are similar, we can say that AM over DG, AM over DG is equals to MC or AC, take AC over DC, DGF. So AMC is similar to DGF, right? So this happens by angle similarity. So from this we can take that AM over DG is the same as AC over DF, okay? So these are the same, and this is a certain constant K. Okay, to make things easier, let us replace AM by H1, DG by H2. So this implies H1 over H2 is the same as AC over dF, which is exactly the same as a certain proportionality constant, right? So from this, we understand that if two triangles are similar, the ratio of the corresponding sides are constant. At the same time, the ratio of their altitudes also constant, right? So this is a very important relationship that you need to take to drive relationship between perimeters and areas. Now, let's see how the perimeter of these two triangles can be related, right? Look, this, we are assuming that the bigger triangles are similar. That is the initial point that we have. If these two are similar, by default, you can have AB over DE is the same as BC over EF. This is the same as AC over DF. Okay, these all are the same and their constant of proportionality is K. So now, from this, let's take each of them and equate with K. Okay, take AB over DE is equals to K, BC over EF is equals to K, AC over DF is equals to K. So whenever you take all these three things, you will drive that AB becomes K times DE. The other relationship that we can take is BC is equal to K times EF. And the third relationship is AC is equals to K times DF. Good. Once we have this thing, now we can create a relationship between the perimeter of these two triangles. Let's say the perimeter of triangle ABC is P1, okay? Say perimeter of triangle ABC is P1. Perimeter means the sum of all the sides, right? The perimeter of ABC means the sum of these sides. So P1 is AB plus BC plus AC, okay? Again, let's write the perimeter of triangle DEF, okay? Say the perimeter of triangle DEF is P2, okay? P2 means EF plus FD plus ED. Okay. Now we know this thing. You can write it in any order. It doesn't matter. So now in place of AB, I need you to substitute K times DE. Okay. Here in place of AB, you can substitute K times DE plus, in place of BC, you can substitute K times EF. And the third one, AC is K times DF. Okay? Here, in all these terms, there is something common, which is K. So this means K times DE plus EF plus FD or DF, right? But DE plus EF plus FD means DE plus EF plus FD means the perimeter of the second triangle, right? This is P2, K times P2. Well, now we can see that P1 is K times P2. Dividing both sides by P2, okay, this tells us P1 is equal to K times P2. Now divide both sides by P2. Okay, whenever you divide both sides by P2, you will have K. Okay, this implies P1 by P2 is K. Okay, now take this. Okay, take a few seconds to compare the relationship that we derived here. we all know that if two triangles are similar, the ratio of all corresponding sides are the same. That means if we have AC over DF, okay, you will have a certain proportionality K. So from this, we can say that if two triangles are similar, the ratio of the corresponding altitudes also constant. The ratio of the perimeter of the two triangles is also constant. So this leads us to the conclusion H1 by H2 is the same as P1 by P2. Okay, you can also say S1 by S2, where S1 and S2 are the ratio, the sides of one triangle, okay, and S2 is the side of the other triangle, okay. So there is a relationship between the ratio of the altitudes and the ratio of the perimeters, the ratio of the sides, okay. So we have this relationship. Next, I will show you how we can drive relationship between the area of these two triangles, right? So now let's see what the ratio of area of these two triangles looks like. Okay. Here we already have a certain relationship. Now let's calculate or let's determine the ratio of the two triangles. So you know that area of triangle ABC is half of the base BC times the altitude H1, right? We have this. Now in place of BC, you can substitute BC is the same as EF times K, right? So in place of BC, you can substitute EF, K times EF, right? You have this thing. The other thing, in place of H1, you can substitute H2 times K, okay? Because H1 over H2 is K. So in place of H1, you can substitute K times H2, right? So now we have K times K is K squared times EF times H2, okay? Whenever you rewrite this thing, you obtain that K squared times EF times H2. But there is also half here. So this is exactly the same as K squared times half of EF times H2. But half of EF times H2 means EF is this one and H2 is this one times half. This means half of EF times H2 means area of triangle ABC. So in place of this, you can substitute area of triangle EDEF. Okay, now we were able to, here we are, so from this, we are able to extract or develop a relationship between the area of the two triangles, right? That means area of one of the triangle, you can call it A1, is K squared times area of the other triangle. Okay, say this is A2. Okay, so from this we can say that A1 is equal to K squared times A2. This implies A1 by A2 is K squared. Okay, but K is P1 over P2 or H1 over H2. Okay, so this is exactly the same as P1 over P2 the whole square. Okay, so there is a relationship between the ratio of the area of two similar triangles and the perimeter of two similar triangles. So let's write this thing formally. So if we conclude that if triangle ABC is similar to triangle DEF, where area of this triangle is, area of triangle ABC is A1, area of triangle DEF is A2. Okay, if we have this thing, by similarity of these two triangles, the ratio of the area of these two triangles A1 by A2 is the same as the perimeter of triangle ABC, call it P1 by P2 the whole square. Okay, since the ratio of the perimeter of two triangles and the ratio of the sides of two triangles, the corresponding sides of two triangles are similar, we can write like this. Okay, S1 by S2, where S1 is one of the sides of triangle ABC and S2 is the corresponding sides of triangle DEF. So these relationships are very important to calculate problems related to ratio of areas of similar triangle, the ratios of perimeters of two similar triangles, right? So now let's see some examples related to this topic. If the sides of two similar triangles are in the ratio, so these sides are the corresponding sides of two similar triangles in the ratio 3 to 5. Find the area of, find the ratio of the area of, the ratio of the areas of, the areas of the two triangles, the two triangles. Okay, here what is given? The ratio of the corresponding sides of two similar triangles are given, which are in the ratio 3 to 5. So what is the ratio of the area of the two triangles? Okay, to answer this thing, you need to apply the relationship between the ratio of the areas and here make it square. And this one, okay? You need to apply this thing. Good. So from our derivation, we can take that A1 by A2 is the same as S1 by S2 the whole square, right? Here S1 by S2 is 3 by 5. That means 3 over 5. Okay? So you can make it square. So this result tells us 9 by 25. Okay? Therefore, the ratio of the area of one triangle to the other triangle is 9 by 25. Okay? So if you have the ratio of two sides in this form, it's very simple to determine the ratio of the area of the two triangles. You can make it square. Okay? Sometimes the ratio of the area of two triangles may be given, and you may be asked to calculate the ratio of the corresponding sides of the two triangles, right? This way, we can answer anything, right? Okay, let's see one more example regarding this issue. Suppose the areas of two similar triangles are 144 centimeter square and 225 centimeter square. Find the ratio of find the ratio of the perimeter of the two triangles. Okay. Here, in this example, what's given, the areas of two similar triangles are given. One is 144 centimeters square and the other one is 225 centimeters square. Okay, this is given. Okay, so based on this information, we are asked to find the ratio of the perimeter of the two triangles, right? So to answer this question, you need to remember the relationship that we derived earlier, right? We have seen that if two triangles are similar, the ratio of the area of one triangle to the other is P1 by P2 the whole square. Okay, this is also the same as S1 by S2 the whole square. Okay, for this specific example, we only need this one, right? We need to take the first two cases. So area 1, say 144 centimeters square, and the second area is 225 centimeters square. Okay, this must be the same as P1 by P2 the whole square, right? So now this implies P1 by P2 the whole square is the same as 144 is a perfect square. You can write it like 12 square, and 225 is also a perfect square, which is 15 times 15 or 15 square. So this is the same as 12 by 15 the whole square. Okay, or you can take both sides by radical. So this implies P1 by P2 is 12 over 15. Okay, this the whole square and this the whole square are the same, means P1 by P2 is 12 over 15. But we are asked the ratio. Always whenever you write something as a ratio form, you need to put in the least simplified form. So 12 by 15 means by 3 it's 4, by 3 it's 5. Therefore, the ratio of P1 to P2 is 4 by 5. Okay, so this way you can answer problems related to the areas, ratio of areas, and the ratio of perimeters, maybe the ratio of the altitudes too. So this is all about the today's lesson. Thank you for listening.